This is a question from an old SAT back before it went digital, and that's why there's so much text. They don't usually do this anymore for math questions. I believe this is a question that had multiple questions associated with this one story. So they don't do that anymore either, thankfully. But still, anytime we see percents and questions, you kind of want to be on alert because reading carefully is a big part of the problem, right? So let's be thorough. So we got this chart of properties and purchase prices, rental prices. The Townsend Realty Group invested in the 5 different properties listed in the table above. The table shows the amount in dollars the company paid for each property and the corresponding monthly rental price in dollars the company charges for the property at each of the 5 locations. Townsend Realty purchased the Glenview Street property. Glenview Street. Okay. And received a 40% discount off the original price, along with an additional 20% off the discounted price for purchasing the property in cash, which the following best approximates the original price in dollars of the Glenview Street property. So they're being really clear about their trap here, right? Original price, we don't know. So this $140,000, we're going to increase that number. And you can see that that's actually true in all the answer choices. But I worry about one where there's no answer choices, right? That some of you are just going to say, what is 40% off of 140? What is 20% off of that? So, you're going to end up with kind of these weird, like backwards percentages where you are actually lowering the price because you treat the 140 as the original. But that's not the case. So there's a couple ways to do it. One of them is just to do it piece by piece, right? So if we use the open formula, when we talk about discounts, we're using the 1 plus or minus P formula because we are changing by a percentage. A discount is a subtraction. So stick to that part first, right? Let's just do the 40% off. 40% discount off the original price. So 1 minus 0.4, 0.4, that's the discount. And again, they use the word original. So it should be very clear that we're solving for the original value. But some of you still really want to put 140 kind of on the left side. I'm hoping that by doing the 1 minus P, the 1 minus 0.4 first, you're kind of realizing that wouldn't make any sense. So this is why the open formulas exist, in my opinion, is we are often asked on the SAT to solve backwards a percentage, right? So the open formula doesn't care about what pieces we're given. If we're given 2 of the 3 pieces, we can solve for the third, no matter what it is. I'm hoping that breaks a habit that many of you have, which is you guys like all of the numbers you get in a story to be on the complicated side, the left side in this case, of the formula. That's just not how the SAT operates. You got to break that habit. Anyway, 140,000 is the new. So we're solving for this original. So x times 0.60 is 140,000. So we're going to end up dividing to get this, not multiplying, dividing, right? Backwards as well. We associate percentages with multiplication, but in many cases on the SAT, we're going to divide. So I did that in my regular calculator. I got 2, 3, 3, 3. Oh my God, too many threes. 1, 2, 3, 4, 5. 4, 5. So $233,333.33. 33 cents. Cool. That is an answer, but I haven't finished the job, right? So that's a trap because then there's an additional 20% off the discounted price. So I got to take that discount off as well. So now I'm working backwards again. So another 20% off means I can now take that. Now there's like a new original. So let's call it Y so there's no confusion. And 2, 3, oh my God, 3, 3, 3, 3, 33. All right, so Y times 0.8023333333. And I know I'm including more threes than I really need to get this right, but whatever. Just trying to set a good example of thoroughness. So divided by 0.8 is 291. Oh God, now there's sixes. 666 and then 66, 67 for rounding. So is that an answer? Yeah, that looks like B. B is the answer. That's it. That's the whole thing. So that is maybe the slowest way to do it, but also it's less chance, I think, of making a mistake, right? So it separates out each step, and in each case, we know exactly what a percentage is and all that. Let's look at some potential mistakes that you could make. Let's actually just zoom in here. I think what a lot of people are going to do, this is wrong. I think a lot of people are going to add the 20% and the 40% and get 60%. Let's see if I'm right. This is wrong. So I think that you're going to get 1 minus 0.6, and that's 140,000. So x times 0.4 is 140,000. So you're going to divide. You're going to get 140,000 divided by 0.4. You're going to get 350,000, which is, yeah, a trap. So that is adding the 2%, right? Adding literally 20% plus 40%. But remember, what's all the math we've been doing here? All the math we've been doing with percents is multiplication and division. Percents are a multiplication and division operation. They're not an addition and subtraction operation, right? So we have the 1 plus or minus p, but that's basically just converting the language of our percentage, right? We talk about a 40% discount. If you go into a store with a 40% off coupon, right? You're not paying 40% of whatever the item is, you're paying 60% of whatever the item is. So the 1 minus p is really just kind of flipping the language that we use for discounts and turning it back into a normal kind of like, we're taking percent of something. But anyway, that's your mistake, is you can't just add those two things together. You have to do them together. But the good thing is the order doesn't matter. Because if we are going to take a shortcut, the way to do it, I'm running out of space here, would be our original we still don't know, but we can do 1 minus 0.40 to get one of the discounts. And then if you want to combine them into one thing, then you got to multiply. So 1 minus 0.20, and that's equal to the 140,000, K being thousands, right? So you can do them in one shot, but you got to still treat them as separate percentages. So really what's happening here is you're doing 60% of 80% of some number that we don't know, and you could guess and check this if you really wanted, and you're supposed to get 140,000. But if you were to divide here, you got to be careful, because a lot of you are just going to go divide by 0.6, divide by 0.8, and if you do this in the calculator without parentheses in the right places, you're going to end up multiplying again. So I don't know what you'd get. I'm not going to bother with it, but you gotta do this part first. So what I would do is 0.6 times 0.8, which I think is 0.48. Yes. Oh, I'm losing my voice in this last question. And then you're dividing 140,000, 1, 2, 3, divided by 0.48, and you get x is 2, 9, 1, and the 6s. Right? So you get the right answer. So I'm going to leave it like that. I'm literally losing my voice as I'm talking here. But that's what percentages will do to you. The language of the question matters a lot. And so that's why I'm doing a lot of talking, is I want to make sure you understand those little subtle things about all of these questions. This one in particular, if you understand it wrong, you will get it wrong. Make sure you are thorough and you will be fine. But if you try to take shortcuts on percentages, you will get them wrong.